Hello everyone. Today we're going to be working on applications of solving equations. So be on the lookout for keywords when solving word problems. Words like sum, total, more, and increased are probably directing you to add. And words like difference, less, decreased are probably directing you to subtract. Unfortunately, there is not really a one-size-fits-all solution to dealing with algebra word problems if you are searching for one. But the more problems you're exposed to, the more comfortable you will get solving them. So you will start to recognize questions of a similar type and be able to focus in on information that is most important to answering the question. So things like gym monthly fees, sales commissions, cab fares, that sort of thing might seem like really different concepts and different problems at first glance, but if you dig a bit deeper, you may notice that they are all variations of the same thing. So, word of advice: with word problems, read the question. Really read it. Reread it. Okay? It is very key for you to understand what's going on with the question. So if you don't even know what it is that you're looking for, you need to really read it, reread it, absorb it, digest it, figure out what it is that you have and what it is that you're trying to find out, and see where you can go from there. So you may find it helpful to try a few simple sample values to get a better understanding of the situation. So maybe if it's a monthly gym fee or a cab fare, for example, you could see what the total cost is if you try a membership for 1 month, 2 months, 3 months, and then you might see a pattern developing. Similar with a cab fare, if you drive 0 kilometers, 1 kilometer, 2 kilometer, that sort of thing, you may be able to stitch together some helpful information. Okay, so after you've read it, after you've absorbed it, you've digested it, you're going to translate. So translate the English words on the page into an equation and solve for whatever it is that you're looking for. So often it is a variable, so generally a good idea to identify what it is that you're looking for. So maybe it might be total cost. So generally you might just say x is equal to whatever it is that you're solving for. That is often a good call when you're solving basic algebraic equations or problems. Alright, so we'll take a look at a few different examples, and hopefully we'll get the hang of it and you'll try some practice questions in a moment. Alright, so question number 1. The value of a car decreased by $2,580 after 1 year. Determine the value of the car at the beginning of the year if the car is valued at $20,000 at the end of the year. So decreased is pointing you to subtract. So we are starting with a value, we subtract this amount, and we end up at $20,000. So if you wanted to sort of translate that into an equation, what is it that we're trying to find in this question? So maybe take a moment. Is it what? So it is the value of the car at the beginning of the year. So it's the original price. So what I'll do is I'll let x be the original value. So that might be helpful for me to set up an equation. So the value of a car decreased by this much after 1 year, and then we ended up at $20,000. So we've got original value, subtract 2,580, and we end up at 20,000. So now we have an equation for x which we can solve. So we can just do sort of inverse operations or whatever. So the opposite of subtracting 2,580, we add 2,580 to both sides. Again, the goal is to try to get the variable on its own. So that is 0. We just have x remaining on the left side, the right side, and 20,000 add 2,580. We get x is 22,580. So that's the original value of the car. And that's what we were looking for. Determine the value of the car at the beginning of the year. And so there we go. Alright, moving on. Number 2. The sum of 6 and triple a number is equal to 10 more than 5 times that same number. So a lot of information to parse there, I guess. So we need to sort of just break it down. So the sum, so that's telling us to add, of 6 and triple a number. So 6, right, we can just 6 and triple a number, so 3 times a number, is equal to 10 more. So more is telling us to add, then 5 times, so 5 times that same number. So we have this sort of thing, a number, so they're not really being specific about what that number is, so we want to figure out what that number should be. So, okay, so let's see here. The sum of 6 and triple a number, so 6 plus 3 times a number, so let's just say x is equal to the number that we don't know, the number, let's go for that. So 6 and triple a number, so 6 and triple a number, so 3x is equal to 10 more than 5 times that same number. So 10 more than 5 times 10 more. So 10 more than 5 times the number. Okay, so that's our equation. So on to solving it. So let's do sort of opposite operations. We want to get all the numbers to one side and all the letters to the other side. So I'm going to choose to bring all the letters to the right side. So in order for me to accomplish that, I'm going to subtract 3x from both sides. 3x minus itself on the left is simply 0. And 6 remains on the left. And 5x minus 3x is 2x. And we still got that 10, so that needs to carry forward. Okay, so great. Now I have all my letters on the right side. And given that choice, I should probably move all the numbers to the left side. So I'll subtract 10 both sides. 10 minus itself on the right is 0. So all that remains on the right side is just 2x. And 6 minus 10 on the left works out to be negative 4. And one final step, I just got to get rid of this 2. So the opposite of multiplying by 2 is dividing by 2. So I'm going to do that to both sides to maintain the balance. 2 divided by itself is equal to 1. So on the right side now, I just have x. And negative 4 divided by 2 is negative 2. So x is negative 2. Okay, that might be right. Let's see. So we're going to verify. So just as a check, we're going to start with the original equation. 6 plus 3, and I found the number to be negative 2. So I'm going to put that in for x. And I want to see if that is equal to 5 times the number I found plus 10. Hopefully you can still see that. So I need to check that the left side is equal to the right side. So I'm not, trying to solve this equation for something. I'm just sort of drawing a line down the middle, and I want to see that this stuff, when evaluated, is equal to that stuff. So I'm just keeping them separate. So the left side, simplify that, is 6 minus 6, right? 3 times negative 2 is negative 6. So we're going to check that. And then 5 times, shouldn't be a 3, that should be a negative 2. 5 times negative 2 is negative 10 plus 10. So the left side, 6 minus itself is 0. And the right side, 10 minus itself is also 0. So 0 equals 0. That's a true statement. So x is negative 2 seems like it works. So looks like we got it right. All right, moving on to number 3. So we've got a gym membership, 2 different places. So gym A costs $75 per month with no initiation fee, and gym B costs $55 per month with an initiation fee of $180. So determine the number of months for which the total cost of the membership will be the same. Okay, so we're going to do by modeling it with an equation and then solving the equation. So you may find it helpful in order to figure out what the equations are for A and B separately, you may just want to see how the rates compare. So number of months, gym A and gym B. So let's suppose I walk into gym A and say, hey, I want a membership for 0 months, let me in. They'll say, okay, we have no initiation fee, and because you're using the gym for 0 months, you pay $0. For gym B, if I did that same thing, let me in, they'd say, okay, we're going to charge you $180, and because you're using it for 0 months, we're going to waive this $55 fee, but you still have to pay $180 just to get in the door. Okay, let's see if we did 1 month. So now we're going to have to start paying at gym A. So that's $75, and $180, the initiation fee got you in the door, and you're paying an additional $55. So that'll bring you to $235 at the end of the first month. Okay, 2 months, we pay an additional $75 for gym A. So that brings us to $150. For gym B, we pay an additional $55, so $235 plus $55 brings us to $290, and so on, right? So we could do for 3 months, 4 months, and so on. Okay, so if we just kind of focus in on months and gym A, you can see that we're going up by 75 each time. So add 75, add 75, and the value of gym A at 0 months is 0. So sort of a handy way to do that. Well, I guess we need to first start off by defining some things. So let's let C equal the cost total, and let's let T be a number of months. Number of months. So my equation for A should work out so that the cost for 0 months is $0. So this 75, right, would be our multiplier, I guess, for lack of a better word, 75, and then T. And if there was a sort of a flat fee, that would be plus something, but there is no additional fee at the start, so it's just 75T. And we can check this. So real quick, if I put T equals 0, then 75 times 0 is 0. That works out, right? If I put t equals 1, 75 times 1 is 75. There we go. If I put t equals 2, 75 times 2 is 150. That works out. Okay, so that is for gym A. And for gym B, we're going up by, let's see here, $55 per month. So plus 55, plus another 55. So if you find that helpful, by all means, sometimes it might help you to present the data in a table. So 55t plus 180. So that would be for gym B. So you can check that that lines up with our data here. If I put 0 months in for t, so 55 times 0 is 0. 0 plus 180 is 180. There we go. If I put 1 in for the number of months, 55 times 1 is 55. 55 plus 180 is 235, and so on. So that's the cost for gym A. That's the cost for gym B. And what we need to do is figure out how many months the memberships, the total cost will be the same. So we want to figure out, like you can see, it's more expensive per month with gym A than gym B, but gym B had that startup cost. So eventually you can sort of imagine that the lower monthly cost for gym B, this $180 startup fee will sort of kind of get absorbed, and it won't be as noticeable anymore. And then gym A just keeps charging you $20 more per month. Okay, so we need the cost to be the same. So cost will be the same. So same means like they're equal, right? So the cost of gym A, I guess we could just put a little subscript there. Cost of A and the cost of B need to be the same. So cost of A is equal to the cost of B. And then you just plug in, I know that the cost of A is 75t. I know that the cost of B is this thing, 55t plus 180. So there we go, 55t plus 180. And now I have an equation. I can solve for t, and away we go. So bring all the letters to one side, and all the numbers to the other side. So it looks like I've already got the numbers on the right. So I'm going to bring all the t's to the left. So I need to subtract 55t from both sides. 55t minus itself is 0. And 75 minus 55 gives us 20. So we have 20t equals 180. And we just need to, one more thing remains, get rid of the 20 on the left so I get t on its own. So divide both sides by 20. 20 divided by itself is 1. So on the left all I have is just t. So t is 180 divided by 20, which is 9. So 9 months. So that's sort of a thing that could inform you to sign up for one or the other in real life. So maybe you're looking at gyms, you're moving to a new place, and suppose you're only going to be there for 8 months, right? Then it would be better to stick with gym A because you don't have to do the startup costs. But if you're going to be sort of around for more than 9 months, it would be better to cheaper than option A to go with. Okay, let me restart. Gym B would be better if you're past 9 months. That's, yeah, okay. And then gym A is better if you're under 9 months. Okay, one more question we'll go through together, and then you'll have a chance to practice. So Stephanie has been offered jobs at 2 different electronics stores. Store A pays $600 per week plus 5% commission on sales. Store B pays $800 per week plus 3% commission on sales. So Let's see. So sales is a factor here. Store A, store B. So if I made 0 sales, I would get paid $600 in a week at store A. And if I made 0 sales at store B, I would get paid $800. So if I was planning not to sell anything, or maybe it was a bit of a, maybe it's not a very popular store to shop at, that sort of thing, it might be better to go with B. But if you're planning on getting commission, that might change. All right. So you could do, like, suppose you sold $100 in electronics. 3% of 100 is 3. And 5% of 100 is just 5. We could bump that up to 1,000 too if you wanted. That might be a little bit more realistic in this example. But let's just say that we're only selling $100 in stuff. So with my base pay of $600, I would earn an additional $5 from this big sale of $100. So that would be $605. And then if I was working at store B, if I made 3% commission on the same item, the same amount of sales, that's $3. So that would work out to be $803. Okay, let's maybe bump that up. Suppose we sold $2,000 of stuff. So 600 plus 5% of 2,000 is 700. So 5% of 2,000 is $100. So we make $700 if we make $2,000 in sales. Okay, and then for B, 3% of 2,000 is something. So that works out to be 860. So you can see that 5% commission can make a big difference if you're considering store A, and 3% you make a little bit less, so you're arguably less incentivized to sell stuff if you're working at store B compared to A. So we can use sort of this outline of the data to make some equations. So model the problem with an equation. So I guess it'd be helpful to define some things. So we'll let E represent our earnings in a week, per week, total. So base pay plus commission. And we'll go ahead and let S represent our sales. So that's like the cost of whatever it is to the customer of what they're buying, and then you make a percent of that amount. So the earnings at A, you'll make $600 no matter what per week, and 5% on the sales. So if you want to take 5% of a number, you change the percentage to a decimal. So hopefully you remember how to do that. What is 5% as a decimal? How do you do that? So you got to divide by 100, and then that's 0.05. So if I want to take 5% of a number, I can just multiply that number by 0.05. So 0.05 times S. So that's the earnings at A. And the earnings at B, we get $800 per week plus 3%. So that as a decimal would be what? That'd be 0.03. So 0.03 sales. Okay, and let's see what we need to figure out here. What would her sales be to earn exactly the same amount of pay? So we want to figure out the sales to to earn exactly the same. So sort of similar to the last question, except this time the money's coming in rather than being paid to a gym. So we want our earnings at A to equal our earnings at B. So I know what EA is, it's that. So 600 plus 0.05S. And I know what my earnings at B is, it's that expression. So 800 plus 0.03S. And now we have an equation with one unknown, S. So we can solve this equation for S, and that would be the sales figure that you would earn the same amount at store A and B. So we need to make a decision. We can bring the letters to either the left or the right and bring the numbers to the other side, whatever we choose. I think I might try to bring all my letters to the left side. So if I get rid of this on the right, I'm going to subtract both sides by 0.03s. So 0.03s, that minus itself is 0. Okay, and then 0.05 minus 0.03 is 0.02s. We still have the 600 there, equals 800. So a bit simpler now on the right. I've got all my letters on the left, so probably going to bring all the numbers to the other side. That's the right side. So in order to do that, I subtract 600 from both sides. 600 minus itself is 0. 600 subtracted from 800 is 200. So I have now, what's going on there? 0.02s equals 200. And I just subtract, sorry, I don't subtract. I need to get rid of the 0.02 from both sides. So divide by 0.02, divide by 0.02. So on the left, all that remains is just an S, and 200 divided by 0.02 is 10,000. So if you sell $10,000 worth of stuff, you'll make the same at store A and store B. If you sell less than 10,000, maybe just take a moment and think which would be the better store probably to work at. Would it be better to work at store A or store B if you typically sold less than $10,000 in merchandise? So it'll be better to work at store B if you sell less than $10,000 because of that higher base pay, less commission though. So yeah, this would be, store A would be a better choice if you're regularly selling more than $10,000 worth of stuff. Okay, so that's it from me for today. I'll get you to try these questions out, and I have something for you in EDSB that's sort of loosely based off of the assignment. So I would recommend you do this first, and then you can start the little activity, I guess, in EDSB, which is based off of your assignment. Anyway, if you have any questions, just reach out, and see you next time.